In today's video, I would like to introduce a very nice problem of mathematical Olympiad competition. Here is the following setup. Prove if n is a natural number, then we have this expression n squared plus n minus 1 quantity square plus n plus number 1 is not a perfect square. Okay, in fact, the most of the time is being asked to show the expression is a perfect square, but this time it came in the opposite way. Okay, so we are going to show this expression is not a perfect square. Okay, in fact, this is very nice problem to work on, so I would be recommend to give that a try to this problem prior getting to the solution. Go ahead, pause this video when you come back to see the full solution. Okay, by the way, don't forget to support us with your like and subscribe. Now let's go ahead, jump into the solution. So by the way of contradiction, suppose this expression, let's call this one as a red star. By the way of contradiction, suppose the red star is a perfect square, which means this expression is going to be written on this form. We'll have n squared plus n minus 1 quantity square plus n plus number 1 equals capital X square, like this. Okay, by reducing this quantity to the smallest expression possible, we will have n squared here plus this n squared, which is 2 times n squared, minus 2 times n plus this n, which is minus n, plus number 1 plus this number 1, which is plus number 2, equals x squared. Okay, in order to build up a perfect square here, it's clearly we are going to take this number 2 as a common factor and to see what's the real image of this expression. So we'll have 2 times is multiplied by n squared minus n over 2 plus number 1 equals x squared. Okay, so actually this one is giving us 2 is multiplied by n minus 1 over 4 quantity square. Actually the first term and the second term are very clear here, because if I'm going to distribute this one is giving us these terms. So first term it will be n squared as we have here. So the second term will have 2 times this one and this one, which is minus n over 2, which is good to go. So the third term obviously is giving us 1 over 16. We need to subtract this term, which is minus 1 over 16 plus this original one, okay, equals x squared, like this. So now I'm going to simplify this one. So we'll have n minus quarter quantity square. So this one is giving us 16 minus 1, which is plus 15 over 16, equals x squared. Okay, so I'm going to distribute this one. I will have 2 times n minus quarter quantity square plus 15 over 16 is multiplied by 2 is going to give us 15 over 8 equals x squared. Okay, so we are going to simplify this one more. We need to clear off this fraction by multiplying both sides by number 8 in order to have this 8 simplified from the denominator. So I will have 16 here is multiplied by n minus quarter square plus 15 equals 8 times is multiplied by x squared. Actually this 8 can be written on this form. 2 is multiplied by 4x squared, like this. So I'm going to put this 16 inside. I'm going to put 4n minus number 1 quantity square. If I'm going to put this one inside, I will have 4 square. It will be multiplied by n, which is 4n. This one it will be multiplied by 4 is giving us minus 1 here, quantity square, plus 15 equals 2. This number 4 will be, this number 4 go inside this one, it will be 2 capital X quantity square. Okay, now I'm going to go through substitution. Let's set 4n minus 1 equals p, okay, and 2x equals q, like this. Okay, so I will have p squared plus 15 equals 2 times q squared, like this. Okay, so previously we're working on this expression and came up with this smallest expression. This number 15 equals 5 is multiplied by 3. I'm going to use the congruence notion here. So by reducing this one to the mod 5 or mod 3, either one, because 3 divides 15 and 5 divides 15. Okay, so we'll have p squared. This one is going to be 0. This one will be 2q square mod 3. I'm going to do the mod 3. You guys, you can check the mod 5. Okay, it will be the same thing. Now we are going to check where a perfect square can equals 2 times perfect square. So I'm going to make the chart here. So we'll have m squared and 2 times m squared. All is going to reduce to the mod 3. So I'm going to check number 0 here. 0 square, which is 0. 2 times 0, which is 0. So this one reduced to the mod 3. Okay, so I'm going to check number 1. 1 square, which is 1. 2 times 1, which is 2. I'm going to check number 2. 2 square, which is 4. Number 4 is 1 more than 3, which is 1. 2 times 1, which is 2. I'm going to check number 3. 3 square, which is 9. 9 is the same as 0 mod 3, which is because 3 divides 9. 2 times 0, which is 0. I'm going to check number 4. 4 square, which is 16. 16, one number more than 15, which is 1. This is 2 times 1, which is 2. So if you take a look carefully at this column, we have the kind of repeating. Okay, so we have 0, 2, 2, 0, and 2. Now we are going to focus on this both columns. Okay, where a perfect square can equal twice a perfect square. If we take a look carefully at each one, we have 1. This is different than this one. This one is different than this one. This one is different than this one. But 0 is given as 0. 1 is different than 2. So a perfect square equal 2 times a perfect square is occurred only at number 0. Okay, only here. So this one is telling us p and q congruent to 0 mod 3. Okay, I'm going to square this one. So I will have p squared and q squared is a congruent to 0 mod 9. Okay, since 3 divides p or q, which means 9 divides p squared and q squared. Okay, now I'm going to take this one and apply it on the original equation, which is I'm going to reduce this one to mod 9 instead mod 3. Okay, so if I'm going to reduce this one to mod 9, for the first term is given as 0. So we'll have p squared plus 15 equals 2 times q squared. So this one is 0 plus 15, because 9 not divide 15, it stays the same. So this one is actually 0, because we have proven q squared is congruent to 0 mod 9, which is 0 mod 9. Okay, 15 is congruent to 0 mod 9. This expression is telling us 9 divides 15, but in reality 9 not divide 15, which is contradiction. Okay, so the assumption we have considered before, we assumed this one is a perfect square. We found a contradiction, which means this original expression is not a perfect square. Okay, so I have done this problem. Don't forget to support us with your like and subscribe. Thank you for watching. We'll see you next video. Bye.